Hello. We're gonna start with a conjunction. So the example that I have for you is -2 less than or equal to x plus 1 less than or equal to 4. So this is a conjunction. Let me write that down without trying to erase everything. Conjunction, because it is -2 less than or equal to x plus 1 and x plus 1 is less than 4. So I mentioned in the previous video that the word and can be omitted because if you see here, this term and this term are exactly the same. Inequalities are facing the same direction, so I can just put it all together as one sentence. Okay? And now we're doing the same operation. Once again, you have to watch out for multiplying or dividing by negative because it'll switch all the signs. Other than that, you're just trying to figure out where x is. So since I'm trying to solve for x, I'm going to subtract 1. And now whatever you do on one of them, you have to do on all of them. So we get -3 less than or equal to x less than 3. And that's end. So now when you graph this one, we go from -3 to 3. And here we include -3, but we don't include 3. So we have a bracket at -3, but we have a parentheses at 3, and it's everything in between. So if we were to write it in interval notation, it'll be -3 with brackets, comma, 3 with parentheses. And pow. Oops. You. And so let's move on to an OR problem. So here's a disjunction. 2x less than 8 or x plus 3 greater than or equal to 10. So first off, we can't put these together because it's not, all the x's are not on the same side of the inequality, right? So it wouldn't make sense to put it together, well, not on the same side, but I mean, we could put it on the same side. But first, it doesn't match, so we can't put them together. And also, it's an OR statement. So it can fit this one or this one, and it's still part of our solution. So fundamentally, it's a bit different from our conjunctions that we've done. But the process is exactly the same. Now I'm working with two separate ones. So 2x is less than 8. I want to solve for x, so you divide by 2, and it's positive, so it doesn't matter. I mean, we don't have to worry about switching the sign. So we get x is less than 4. So this is the first part. And then if we solve this one, we can subtract 3 on both sides. So we get x is greater than or equal to 7. So we have these two statements that we're putting onto our graph. So let me write 4. Here's 7. So if we're to graph x is less than 4, it'll be a parentheses facing that way and everything below. And if we want to do x is greater than or equal to 7, it includes 7, so it's a bracket, and it's everything beyond that point. And it's an OR statement, so it can be part of here, so it can be a number here, or it could be a number here. So it doesn't have to be overlapping. With the AND statements, you have to find out what they have together, but the OR statements, it can stand as two separate things. So here, the way you would write it is, so one section is -infinity to 4, and then the other section is 7 to infinity. And OR, you denote it by doing the U in set theory, or you can write OR. Doesn't matter. So this overall is the solution for this compound inequality. And next video, we're going to look at an application. Your favorite.